Guys, so I hope you are doing well there. So in the last lectures we have gone through depth first search and breadth first search, and you have seen that they are blind search techniques, means uninformed search technique, and there we were talking about informed search techniques also. So today I am going to discuss one search, informed search techniques, and if you have not gone through the previous lecture, you will find a link below. Go and check it. Okay, so today's class will focus on best first search. Best first search. First point you have to remember about this algorithm or about this searching technique is that this is a greedy search techniques, and you know that greedy search techniques means what? You are not satisfied, means your searching technique is not satisfied with the current state. It is always trying to find a better one. Okay, then next thing you got it that this is a kind of what? Informed searching technique. Okay, so as the informed search techniques uses or applies what? Heuristic function. So it uses the heuristic function to determine a node that is closest to the goal node, or the goal node, that is the node that we are searching for. Okay, and for that a priority queue is used. Don't forget that in best first search technique what we use is a priority queue. Okay, so let's discuss the steps of this algorithm step by one. So first step is that you already got it that we have two lists, open list and closed list, that we have discussed in the last lectures. Okay, so that will be used in this algorithm. Okay, so the starting node is placed at the open list. Okay, so open list, we first place the starting node. Okay, then if the second step says that if the open list is empty, then stop and return failure, means searching is going on, so, and in the open list there is no node available. Okay, in that case we will return what? Failure. Then step 3, means if this is what we come to here, step 3, remove a node, say n, which has a lowest value of hn, that is heuristic function value, from the open list and place it in the closed list. So from the open list you will have different nodes, and from them you will pick that node which has the lowest value of hn. Okay, then expand n to generate its successor. Now as we have picked up the node n, we'll generate its successor and we'll place that node n in the closed list. Okay, as we have generated its successors. So step 5, check for every successor of n whether it is a goal node or not. If it is a goal node, then just return success. Otherwise you have to go to the step 6. So among the successors of the node n, if we find some one of them is our goal, then we'll return success. Okay, otherwise we need to go to the step 6. And what does the step 6 says? Step 6 says that for each successor, check for evaluation functions fn, then check if the successor node has been either in open or closed. If not any of them, then we need to place it in the open list. Got it? So what does it mean? So if for every successor, first we'll check whether the evaluation functions fn is already there or not, and also if it is in the open list or closed list. If it is not any one of them, that we need to place it in the open list, as we have found out its fn value. Clear? Then step 7, return to 2. Return to 2 means what? This process means will be going on until we have been left nothing in the open list, means if the open list is empty but we have not found out the goal node, then in that case it is failure. Or in this step we will find the goal node and then we will return success. So, okay, so these are the steps involved in this best first search algorithm. Let's discuss an example to have a clear idea on that. For that, I have considered this graph. Okay, this graph I'm considering. So you will see that we have the nodes S, A, B, C, D, E, F, G, H, I. Okay, and for every node we have this table where the values of ascents are given. Okay, ascent means heuristic function value. So for A you'll see 12, similarly for B 4, like that. For other nodes also we have this value. So let's begin the best first search for this S, and this is the goal. Z is the goal here. So you'll see that first of all we'll start from S, and S has these two child nodes, successors. Okay, so in the open list we have AB, and in the closed list, as we have evaluated S, we have generated the successors of S. So S can be put in the closed list. Clear? Then from A and B, first of all, which node we have to pick up, that will depend on the ascent value. See, for A, ascent value is what? H of A is 12. For B, H of B is 4. Okay, so which node we have to select? We have to select B here. Why? Because B's value is less. So B will be evaluated, means its successor will be generated, and that B value will be put in the closed list. So already we have S, now B is put, so we have SB in the closed list. Now as we have generated the successors of B are E and F. So put them in the open list, E, F, A, because they are not already in the open list and closed list. So as the step 6 says that if they are not in the open list or closed list, then first of all we have to put them in the open list. So we have put it. Clear? Now from E and F, which node we have to select? The same thing for E. H of E is how much? H of E is 8, and H of F is how much? 2. So can you tell me which node I have to select? Yes, you are right. So we have to select what? F, because F has the heuristic value 2, that is the lowest in this case. So we need to put F here because we have now generated the successors of F, and they are I and Z. So in the open list we have E, A, I, Z, and in the closed list we have S, B, F. Okay, so now we need to check whether the successor, any of the successor of this, in every cases we need to check whether any of these successors are is our goal node or not. If that is the goal node, then we need to return success. Now in this case you have seen that Z is the what? Z is the goal node. So of course we have obtain, or means we have our search is successful, we reach to the goal node. So this is our particular path, that is S. Okay, so S from S we have selected B, from B we have selected what? F, from F we have selected Z, because Z is the goal node. So in the open list we have what? E, A, I, and Z, as it is been it is the goal node. So we have S, B, I, S, B, F, Z in the closed list. So as Z is the goal node, so this is the required path to search the goal node. So that is the way exactly we have to search a goal node in a graph or any particular tree for a best first search algorithm. Okay, so what is the advantage of this algorithm is that if there is a goal node, then obviously it is going to find it. Okay, but this means what? Complete. But about the optimality, we can't say that whether it is optimal or not. So I have a question to you guys, that in which case best first search algorithm will be optimal. Okay, so if you got the answer, then you can comment it, I'll go through it. So guys, I hope this best first search algorithm is very clear to you. First thing you have to remember about this algorithm is that this is a greedy search algorithm and this is an informed search algorithm. If there is a goal node, it is obviously going to find it out. Okay, and the way how we need to find it out, you already got it, and we are using a priority queue to implement this algorithm. So guys, in the next lecture, I will discuss A-star algorithm, and that will be also a very interesting one. And so we'll meet in the next lecture. Till then, take care. Bye bye.